2.1 relations and functions. So let's do this worksheet. State the domain and range of each relation. Then determine whether each relation is a function. If it is a function, determine if it's one-to-one, onto, both, or neither. So for this first one here, we're going to first tell the domain range. Well, here's a little hint. The domain's always going to be the x, range is always going to be the y, or the input and the output. So this is my domain. This is my range. Is it a function or not? Well, we got to see if all these go to separate things. There's not that each x is unique, I should say, right? Do these have only one thing it corresponds to? And they all do. So it is a function. Is it one-to-one? Well, that just means that do they all go to separate things? They all do. So it is one-to-one. Is it onto? Onto just means that every value in the range get taken up. And in this case, it does. So it's one-to-one and onto. It's both. Next one here, well, domain and range. Domain, range. Is it a function? Now, is every value in the x unique? So there's only one a, there's only one b, there's only one c. So it actually is a function. Is it one-to-one? Do they all go to separate things? No, they don't. They all go to the same value, so it's not one-to-one. Is it onto? No, it's not, right? E, F, and G don't get a play. So this is just a function. Over here, domain range. Is it a function? No, it's not. B, there's two B's, right? So BD and BE. So there's two B's and there's also two C's, so it's not a function. D and B and C are not unique. Another way to think about that is if you actually write it out, like you get DB, DE, CF, CG, right? And you have two of the same x values, so it's not a function. B here, domain would be here, range would be here. Is it a function? Well, again, notice all the A's, all the values in the domain are separate. There's only one A, one B, and one C, so it is a function. Is it one-to-one? They all go to separate things? No, they don't. A and B both go to 1, so it's not one-to-one. Is it onto? Did everything in the range get used? No, 3 doesn't get play. So it's just a function. D, domain and range. Is it a function? No. 5 is the problem. There's two 5s. There's 520 and 535, so not a function. E, domain and range. Is it a function? Right? So A is by itself, B is by itself, C is by itself, D is by itself. It is a function. Is it one-to-one? Do they all go to separate things? No, they don't. B and C both go to F, so it's not a one-to-one function. Is it onto? Does all this get taken? And yes, it does. So it's an onto function. So then we get to these, and it's kind of the same idea. So these are all like points. If it helps, you could write it as like, I guess it's the same thing. But it might help to see. Oops. Is it a function? No, it's not. Because right here, they both have two 1s. So it's not a function. Or if you look at here, right, it doesn't pass the vertical line test. So not a function. Over here, let's look at this one. So they give you a table. Well, there's only, all the x's are separate, so it is a function. Is it one-to-one? Do all these go to separate y values? And no, they don't. -2 and 1 both go to -4. Is it onto? Well, that's a question. They don't tell you what the range is. So anytime I give you a table like this, if I don't actually tell you what the range is, I can't see if I'm using all the range. So we're just not gonna, that's not gonna be a question we answer here. So on this one, the table below shows the population of several states and numbers of U.S. representatives from each state. Identify domain and range. So in this case, it looks like my domain is population and my range is number of representatives. So there's my domain and range. I guess my domain would be pop, and my range would be number of representatives. Does my graph represent a function? All you check is all your x's separate. So are they all separate things? Right? These could all be the same. I don't care. It's all about the domain. Are they all separate? And yes, they are. So it is a function. All values in domain are unique. There you go. Graph each function, determine whether the functions, determine the domain and range, determine whether each function is a function one to one onto, then state, oh, actually we don't do that last part. So I know some of you guys know how to graph already. In 2.1, we actually don't know how to graph these things yet. So we're just gonna make a table. So I do like -2, -1, 0, 1, 2. We're just gonna substitute our values in. You plug in -2, I get 6. 6 plus 2 is 8. So -2 and 8 up here somewhere. Plug in sub in -1, so I get 3. 3 plus 2 is 5. Right here. Sub in 0, you get 2. So put that down. Sub in 1, I get -3 plus 2, that is -1. And then sub in 2, you get -6 plus 2 is -4. So it's looking kind of like this. Not my best straight line ever. Domain and range. So my domain, I mean, we haven't talked about all the numbers yet, but based on this, it'll be these values. My range will be that. Is it a function? It does. It passes the vertical line test. So yes, it's a function. Is it 1-to-1? Does it pass the horizontal line test? Yes, it does. So it's a 1-to-1 function. Is it onto, again, I mean, in this case, it would be yes because it take every value in the range, but they don't really specify. So say it's a 1-to-1 onto function. Let's look at this one. So same idea. We're just going to plug in a couple numbers. I plug in -2. -2 squared is 4. 4 times 2 is 8. So -2 and 8, again, way past my graph. Plug in -1. -1 squared is 1. 1 times 2 is 2. Plug in 0. Sub in 0. You get 0. Sub in 1. You get 2. Because 1 squared, remember you squared the 1 first. So I plug in 1. It's 1 squared. So I do that first. And then I times it by 2. And then same thing with 2. And then, well, in that case, it does still matter. So you plug in 2. 2 squared is 4. 4 times 2 is 8. You get this thing. Nice parabola. So, domain and range. So over here, let's put all real numbers so you actually have an answer. That'll make more sense later. So my domain to all the x's, like it all gets taken. We'll just call that all real numbers. So you could write all real. Okay, we'll talk about this more later. Or you could write, it's like a fancy R. The range here, if you look at it, though, doesn't use all the numbers. It actually only starts at 0 and goes all the way up. So it's it's from like 0 to infinity, or just all the positive numbers. I guess plus 0. 0 is not positive or negative. So that's my domain and range. Is it a function? Does it pass the vertical line test? Yes, it does. So it is a function. Is it a 1-to-1 function? Remember, to do that, you do the horizontal line test. In this case, no, it doesn't. It's not a 1-to-1 function. Is it onto, again, they have to tell you what the range is. If the range was all real numbers, then no, it's not onto. If the range was from 0 to infinity, then yeah, it is onto. So onto is a little trickier. I only ask you about onto when I give you one of these, the mapping diagrams. Because that way the range is stated. Okay, so find each value. F of x equals 3x plus 2, g of x equals that, h of x is that, find f of -5. So again, all we do here is sub it in for our f values. So we're going to sub into this equation. Right, that's all f is, and then we're going to sub in or plug in -5. Then we simplify, -15 plus 2 is -13. And that's it. That's the answer. Right? If you want to write it like this, you can, because it is a relation. But all that means is when I sub in -5 into this equation, I get -13. So there you go. This one, I guess, h of 3. So same idea. We're going to plug 3 into the h equation. So -4, 3 squared, -2 times 3 plus 5. So we get -4 times 9 minus 6 plus 5. -36 minus 6 plus 5. So -42 plus 5. So -37. So again, that's just my answer. When I plug in 3, I get this. H of W. So let me write it the other way again so you can see it. So all this means is here's our function. X's are just placeholders. And what happens here is we're plugging W, just like we plugged in -5 or 3, right? So now, where is the next? I plug a W in. And there's my answer. We're going to do the same thing over here with f of fw plus 5, w plus 2. So I like to write what f is. F is this. Right, that's what f is. F is a function that does 3 times whatever plus 2. And when the whatever in this case is w plus 2. So distribute, and you get 3w plus 6 plus 2, which is 3w plus 8. Right? Don't get scared when there's variables there. It's the same thing, just plug it into the function. That's all this is. Oh, I want to plug w plus 2 into the function? Just plug that into the function. There you go. Podcast. Oh, how topical. Chaz has a collection of 15 podcasts downloaded on his digital audio player. Okay. He decides to download 3 more podcasts each one. The function p of t equals 15 plus 3t counts them are podcasts. Eventually, Chaz, you have too many podcasts. So here's the thing about this is that p of t, you have to know what each variable means. So the number of podcasts is p of t. So that's how many podcasts he has. And t is months. So in this equation, number of podcasts, months. How many podcasts will he have after 8 months? Well, this is my t. So just unplug into the equation. P of 8 would equal 15 plus 3 times 8. So it's 15 plus 24, which is 39, which is probably low, way too much podcasts. Reasoning. If a graph of a relation crosses the y-axis at more than one point, is a relation sometimes, always, never a function. Explain your reasoning. So let's just draw this out. So you have x and y. What it's saying is you're going to cross the y at more than one point. So not like this. Well, in this case, it's not a function. Never, right? You're going to have 2 same y values. 1 x value for 2 y values. So it's not a function. It's never a function. It does not pass a vertical line test. What's the difference between a relation and a function? Is there a relation a function y? So a relation is the coordination of any 2 points. A function is a relation where every x value is unique or different. So it's a special type of relation. Is every relation a function? No. Refer to that. Next one. Let a be -1, 0, 1, 2. Consider a rule f of x equals x squared. Find domain and range of the function. So my domain is also known as the input. It's stuff you plug in. So they gave me the domain already. It's this guy. My domain is going to be -1, 0, 1, 2. There's my domain. The range is the output, what you get back when you sub it into the function. So if I square -1, I'm going to get 1. If I square 0, I get 0. If I square 1, I get 1 again. If I square 2, I get 4. Now, 2 of these are the same, so I don't have to write them twice. I just have to write them one time. So 0, 1, and 4 will be my range. Alright, so domain's the input, so I'm plugging these in. That's my domain. Range is the output. So when I plug these into the equation, what do I get? Open-ended. Graph relation that can be used with the following. So you saw the graph these. The height of a baseball that's hit onto the outfield. I don't know, so you start at like what, 6'5" something? That was the batter's stances. Then we hit a ball, so it's gonna go up and then it's gonna go back down. Right? Hit it, goes up, and eventually it comes down. Either gets caught by somebody or hits the ground. The speed of a car that travels to a store, stopping at 2 lights along the way. Okay, so you start at 0. So you start the car at 0. Then you rev up. You go faster. I mean, from here it's kind of your choice, right? Like, do I hit max speed at some point? Like, I don't want to break the speed limit. Then I gotta stop for a red light. Then I gotta start again. I can stop. Then I stop again at a red light. Then at some point I imagine I actually hit the store, so I gotta stop again. But it's kind of all variable. You need at least 2 of these. It doesn't actually to tell when it ends. The height refers from age 5 to 80. So at age 5 you're on some height around here. then you grow. I can go massively tall unless we're playing basketball in the NBA. And at some point you hit a plateau, then you might shrink it a little bit when you get older. So something like that. D, temperature of a typical day from 6 a.m. to 11 p.m. So this would be temp. I probably should label these, and this would be the time. So here's 6 a.m. Right, so I know who knows what the temperature is, but eventually it gets hotter, especially in California, and then it's at some point to cool down again. So something like that. And that's this worksheet.